Welcome everyone and thank you for coming at our second day of our PCF event. Before starting, I would like kindly ask you if you can hear me, you can see me. So, since everyone is here, we should get started. So my name, for the one who didn't join yesterday, is Ambrogio Paoletti, and I'll be the moderator and the presenter of this event. I would like to remind you, in case you're facing some connection issues, you can address it to our technical support, Sarah, on the private chat, and she will provide you prompt assistance by writing her from the private chat. Nevertheless, I'm glad to welcome you at the second day of the second annual Smart Livestock Farming online conference. Today will be, of course, mainly focused on the animal welfare and on the animal nutrition. And the key points that we would like to cover today are the newest technologies in animal welfare, how to integrate the technology in the animal nutrition, and the quantity versus quality. So now let me introduce our today presenters. So we start with Ziv Dubinsky, the founder and the CEO at Metabolic Robots. He will present the case study, Nutrition Welfare, Technology that Betters Performance. Then we continue with Leni van Herpen van der Kooi. She's a professor in precision livestock farming at the Haas University of Applied Sciences. She will present the case study using precision farming to improve animal welfare. After her presentation, a small coffee break, and of course, will be offered by our sponsor, Semstech. And after the coffee break, we'll have Dr. Steve Krause. He's the Executive Vice President, Sales and Marketing at Semstech. He will introduce the case study, Fertility Management in Rodents to Improve Farm Operations. And the last presentation will be held by Daniel Martins, the CEO at Agriplant Inovação Rural. He will present the case study, it is better selling more products or focusing more on quality. So as you can see, it's a full day of knowledge, it's a full day of case studies, and I hope you will enjoy the 2.5 hours of conference. So I would like just to remind that all the post-conference materials, which includes the video of the whole conference, the PDF presentation from all the speakers, and the contact details from all the participants will be sent between 1 week or 2 weeks. I just would like to remind you that during the first presentation, if you could please write on the chat if you prefer to be strict with the program or to dedicate a little bit more time than we have in the program to the Q&A sessions. Thank you. So now let's start with the program, and let's start with our first presenter, our first keynote speaker. Is Ziv Dubinsky, the founder and CEO at Metabolic Robots. He will present, as I mentioned to you previously, the case study, Nutrition Welfare Technology that Betters Performance. So now let me introduce Ziv. How are you today?
Hello, Ambrogio. Thank you for the invitation. I'm doing just fine. Hello from sunny Israel. It's getting warmer here by the minute. So I hope you're feeling cool wherever you are sitting and located in. I will today like to present for you a case study that I've been doing since 2009 until 2017. It's a long case study on poultry, and with your permission.
So let's wait for your sharing screen, and then you can start.
Yeah. So I'll start the presentation.
Here we are.
Here we are. So
All right. The page is yours, Ziv. See you later.
Thank you. So as you can see in the first slide, Metabolic Robots is the company that I founded for doing this preliminary test, the proof of concept of the technology. Really, I got into poultry as I was living in a farm, a village, and as a city boy, I really wanted to look into agriculture and find what technology can do better for the agriculture, and poultry was the main and still is the main industry and the biggest industry. With this case study, with this technology, we also received the Seal of Excellence that was given from the Horizon program in the European nation. The Seal of Excellence is given to programs that are okay to get grants, but sometimes grants are not, the money is not there, so they give up these seals. So what is the precision agriculture with chickens and with technology, and why does it matter? Because as we know, the doctors and veterinary people in the industry, they give us the principles for welfare, they give us the principles for the measuring and for the parameters we as farmers should look at when we are growing flocks of animals. And then it's usually it's a black box that it's a process that is remotely monitored sometimes, and sometimes farmers visit the growing environment once a day or twice a day, and the really dedicated farmers visit the barns, the broiler barns, the chicken barns that are going to be meat a couple of times a day, and management can really do a lot in this industry before we introduce technology. So when I looked into this chicken industry, I tried to monitor what is happening inside the chicken house when no one is looking, and when cameras really can show us a whole flock, a whole bunch of animals, sometimes as up to 60,000 animals in very dim light conditions. So cameras could not tell us a lot, especially nothing that can be qualified as data. So I decided to monitor the feed lines and to measure the amounts of feed these animals intake throughout the day, divide this to the amount of animals, of course, and build an algorithm that will eliminate any noise to the data. And what I mean by noise is the huge epidemic that I've discovered that is an integrated part of the chicken industry, and this is the epidemic of the empty feed lines. When no one is there in any barn around the world, I guarantee this, when we monitor the feed lines, we will find out that sometimes there is a part of the feed line that is empty. Sometimes it's for half an hour, sometimes more. Sometimes it's the full feed line, and sometimes it's more than one feed line. And as you can understand, the feed lines are really the production floor of this industry. The feeding is really the production, and the chickens are the workers. So these are the some photos from the actual tests. As you can see, these are the chickens. They are drawn to anything that is interesting. In this case, as you can see in the photo, they are drawn to they are looking at nothing. There is nothing there. There is just a source of light. So not only food, anything that can draw the attention is really moving the flock. There is nothing there, and their life is consisting is really of noises that are made by the mechanism that brings them the food. And these noises are the things that are running the daily routine and the group dynamics. Now, when there are empty line, these noises mean that there is no, can mean that food should be coming, but there is no food coming, and then it makes quite a dissonance with what the chicken believes in. When it hears the noise, it believes that food should be coming, and the food is not coming, and then it stops believing it, and its behavior changes. This micromanagement is what we are trying to, what I'm trying to accomplish in changing by algorithms that will control this feeding mechanism and guarantee feed is coming anytime the noise is heard. In the middle picture, you can see the big box. This is the system that was in the tests, and it has a smaller smartphone size touch screen for the control of the farmer if he wishes to. And since the tests, it got a little bit smaller, and today it's really the system is really about the size of a shoebox. So our issue here is putting a spotlight on the real problem that the technology monitored and pointed out that is currently in any broiler house. When the houses are as better management there is and as newer the equipment, the problem is sometimes more minor, but you will soon understand what is this graphic here that you can see the sun of inefficiency. This is not just some painting that someone made. This is something that the AI made. This is a painting that the computer made. And if you'll understand what it means, you will see the beauty of data and what it can teach us. Now we can also see the platform that I've used and I've built and used to monitor the behavior of feeding by animals in the chicken house. And the algorithm, what it does, it monitors the feeding minute after minute inside the chicken house. And when it finds a gap that is getting larger in feeding in a certain area, it raises a flag, and this can mean there is a disease that is starting to contaminate this area. This can mean there is a water problem in this area or some kind of engineering problem in this area. With this kind of information on how animals feed in each location in the building, and each building in the world is different, okay? There are no two same structures. Although they can stand one next to another, the animal behavior in each structure during the growing stages, during each of the days, will be slightly different, and each barn is a data cloud. We cannot rely on a general graph for the animals. Each barn is a data cloud, and each barn and the animals that grow in it cycle after cycle, because they come from the same genetic lines, in the same barn, they behave the same like the generation before them. The barn, maybe it's the magnetic fields, maybe it's something else, but the location determines the behavior of the animals cycle after cycle, generation after generation, and this can help the machine learning, the AI, to predict the behavior of the animals in this location if we use the same genetic line. And with this prediction, we can also predict what is going to be the needed feeding, and if it's not there, so maybe it's the problem. So how did the tests look like? How does it look like? That's me with the mask, and this is required because when you are standing inside this environment of tens of thousands of animals, there are a lot of toxic gases in there that are probably okay for the animals that are low on the ground, but people can't really stay for a long duration inside animal habitat. As you can see, I located sensors throughout the lines in 2 or 3 locations. We can work with one sensor at the end of the line, like today, but it's better if if we spread 1 or 2 more sensors throughout the barn. And in this way, we can also control part of the barn, feed part of the barn, and also control part empty feed lines. We tried it with proximity sensors and also with regular sensors of on and off. This is how the touch screen looks like. This touch screen was with a test with Big Dutchman that I believe everybody here knows. With barns in Germany that have around 1.4 feed conversion ratio, it was really hard to believe that these German chickens can do any better, because a farmer has got 2 barns and the chickens get all the best attention and the best feed. But yet we did find empty feeding lines, and we did manage to better the FCR also in German barns. So the farmer only has to push start at the beginning of the batch, and that's it. He doesn't need to pay for communications. He doesn't need to pay for anything. Everything is free. I'll get to the architecture in a few slides. This is a frightening screen. It's not my technology. This is Big Dutchman computer that monitors chicken barns. Okay, so what you can see here, that the 4 upper lines are really full of activity. This activity is electric activity that runs feeding motors. Each barn has 4 motors. So the upper 4 motors are the control barn, and the 4 motors at the lower part of the screen are the metabolic robot test barn. And as you can see, also with electricity, the chickens are the same, the feed conversion ratio is better, and we also save a lot of power, a lot of electricity, because the computer runs the feeding lines when needed. And probably you can understand that all the extra white lines on the control barn is empty lines. It's water that is running on empty. And this is in Germany, ladies and gentlemen, sorry. So now I will try to explain what are these sun of inefficiency. So these 3 sun images that you see at the bottom of the screen are really 3 feeding lines, and each circle is the clock is 24 hours. And whenever the line is empty, the computer colors this time slot with a yellow color. And each day that the line is empty at the same time, the color gets dark. So as you can see, there is one feeding line that is empty again and again, day after day at the same hours. And there are different empty times for each line because the flock is slightly migrating. And as you can see at the upper chart, this is the feeding trend of the actual real feeding trend of the flock throughout the days. When you can see at the day 28, 30, around there is a part of the flock is going to market. So we can see anything. We can see vaccinations, we can see problems with management, problems with lightning, anything affects the feeding habits. So what is possible with monitoring and controlling feeding of chickens. We can have live alarms for anything that goes out and affects the animals. We can have reports that demonstrate the barn, and you can also compare with different locations and then find out about better genetics or better feeding. You get real-time analysis of your performance in the barn. How much how they're expected to eat, and how much are they eating, etc. You can have predictive analytics about disease outbreaks and about mechanical problems like empty lines. You can come to the barn at the hour of the empty line and manually, as a good farmer, manually operate the semi-automatic system, and then you can watch it respond on the sign of inefficiency as it disappears, and you know that you've gained some more percentages by micro managing your barn and coming to this location at the needed time and not at your convenience or at the staff convenience. The communications can be free or can be very cheap because they can rely on LoRa communications, on Bluetooth communications, or SMS, or any kind of communication that is cheap in your location. And we will give, or the company that will do this service will give 24/7 service for the farmers to first get to acquainted with the system and understand what they are seeing and how they can spot the problems and fix them. Now for the professional chicken guys, this is how the industry numbers look like. And as you can see, when we measured, we got a significant decrease in feed conversion ratio that translate into around $60,000 per one barn each year that can be saved or gained by a farmer from each house. If he only puts a $400 system that will manage the feeding for him and will tell him when are the best times for him to visit the barn to even better his performance. This data and the information was gathered by industry experts that were assigned by the science office here in Israel, because they gave me the grant to go on and study this industry and bring the proof of concept that something can be done. This system is an add-on to any barn, new or old, as long as it's pan feeding, and it's been pan feeding since the 1950s, when this industry really started working semi-automatic, and there were no changes since. So I believe this is the next the next step for the industry to become really the next generation. And with this, I am finishing my presentation, and thank you again.
Thank you, Ziv. Thank you so much for your time, for your presentation. So we have already 3 questions. So let's move to the first one. So still really good comments of fascinating technology. What do you find to be the leading causes of empty feed lines?
Well, for my experience, empty feed lines usually happen in certain ages and in certain areas of the barn. So you need to identify each barn with the ages that are problematic in this location and the lines that are that has the most problems. And when you identify it, it will be consistent throughout the next flocks.
Okay, thank you, Ziv. Let's move to the next one. So, hi, Ziv, and thank you for your presentation. Another good compliment. So, how many farms did you equip with your system until now?
Yeah, thank you. So, since in the beginning, I went to farms in Israel for around 8 farms in Israel, and I made a mechanical device that really was time consuming because I had to come each 2 or 3 days for each farm and move something and try to look at the data from the farmer. It was very hard. But as soon as I made the computer, I built 20 systems and deployed them in 4 countries, in Ecuador, in Germany, in Estonia, and in Israel, in 20 different locations. And then it worked for 3 years. So it's around 50 or 60 batches. Now from that, we should clear all the sick batches, and we should clear all the early marketing and all sorts of problems of logistics, and disease is really wide. So we had to filter through everything to get clear batches, and only then the industry expert could draw the numbers. And the numbers, the clean batches is around 16 batches, and this is after 3 years and 20 locations. We only get 16 clean batches that can be academically studied, and from these 16 batches we have significance for FCR, but not yet significant numbers for weight, although we've seen weight as a flock, not individually, but as a flock. The flock weight for marketing was higher. It's not yet significant because there is not enough testing at this point.
Thank you, Ziv. So let's move to the, well, let's say are two different, we could say are two different questions, anyway, from the same attendee. So hi Ziv, very interesting presentation. What else are you monitoring besides feeder lines, or intend to monitor in the future?
Thank you for the interesting question. So no limit for what we can monitor, and no limit for the data we can rely on or make somehow useful. But as I got the scientific grant for using it for something that does not exist, so I ignored all the existing systems that monitor environment or water or silos outside load cells, or even the mixers in the room before the growing room. I ignore everything, and I only monitor the switches of the feeding lines. That's it. And from this, I can grow all of the information because everything is seen by the animal's behavior.
All right, thank you. Let's just a way to display first of all your email address, who's here, because you have any inquiries.
Yes. Thank you. I'd be happy to be in touch with anyone that is interested in facilitating tests, or maybe become a partner, because we have not yet reached the commercial part. The grant wasn't allowed for that, so I'm still waiting for partners or a big company that will adopt this technology. Thank you.
And in the meanwhile, came another, is a long question, so I have to divide in two different banners, or even 3. Yeah, well, I actually have 2 questions plus, let's say, a comment. Let's give it just right now. Actually, I have 3 different questions. Yeah. Right, so let's move to the first one. Hello, Ziv, and thank you a lot for your presentation. You mentioned $400 system. Is it per barn, including the robot box setup, or wall and sensors?
Yes, this is for the wall unit that is placed in the electric shed. The sensors are really the end plates or middle plates from any company you'd like to buy them from, Roxel, Plason, whatever switch pens, it's okay. We then run them on 12 volts, so they are no longer connected to the motors directly with high voltage. they are connected to the box, and the box is the one that is running the relays for the motors.
All right, so let's move to the next one, and which is as well from the same person. I've seen that you had to keep for free farms in Israel, leading to extra income for farmers and supermarket. How do you make returns on this?
Supermarkets and farmers are really not the same here. It's the market is held by companies that own the chicken barns, and the supermarkets are different companies. I did not connect to the cash flow of the farmer. The farmers that were in the test, they supplied the data not because of any financial issue. The tests were done, part of them for free. Part of the some of the test sites, farmer also wanted to buy additional systems for the test system, and I sold them some beta systems for them to operate. But since really the free beta tests for us to get the data, I haven't sold any systems. The $400 is the expected price from the hardware that is inside the box.
All right, thank you. So this is a little bit more personal. So I don't know if you do follow us. Yes. So did you and Jason Jordi from the presentation meet to compare your system? Actually, I believe you don't know each other. Well,
No.
your technology, if I can comment, is more related to the animal welfare. His technology is mainly related to the tracking. So it's could sound, but could be similar.
I've gone over the speakers to get to know who is in the conference with me, and I've seen the systems of the tracking. It's really a different field. It's also cattle and not chickens. When in cattle, the main issue is tracking the individual animal. When in chickens, we are working statistically. It's tens of thousands of animals each 6 weeks, give or take. So sensors for individual animals is really expensive and not really interesting for me. So I'm working with the mechanics that are on the farm. I'm only monitoring them differently and using the farm in a more intelligent way, not like in the 50s of the last century.
Right, so let's move to the next question. So when you say you see anything in the behavior, you mean feeding behavior, or do you have cameras as well?
Yeah, it's feeding behavior. Of course, I see change in feeding, in expected feeding in different locations as we can put 3 sensors at the end of the line. We can put 6 or 9 sensors, 3 sensors throughout the line, and then have 12 sensors in a 4-line barn. And then the structure is like divided into 12 sections, and each sensor has its own data. And then we can know the predicted feeding in this area. And if there is a problem, the feeding behavior changes. It usually drops. And then we can raise the flag for the farmer to go and check. I don't know what's the problem. Maybe someone stole the chickens. And in some cases, we saw someone stealing the feed from outside the barn. So the chickens stop eating because there is no feed. So we alarm, and they came and they said there is someone stole the feed. So anything is visible. The farmer is remaining the manager of the farm, and he has to go and look what is not okay. It's an intelligent tool, but it relates only to feeding. It draws the data from feeding, and this is what it monitors, the feeding system.
Yeah, and about it, there is I have to make it a little bit later, this question, but there is a question they made from the attendance regarding about the feeding. So, but of course, let's make the question in a chronological order. So, First of all, there's a comment. Thanks, Ziv. Would like to get to know more about your system. Of course, just I will display once again the email address.
The website, yeah. Website also is also there are some photos there and some information also on YouTube. There is also just click Metabolic Robots on LinkedIn. A lot of posts from all of the years of experiments.
And I believe the website is www.metabolic-robot.com.
Yes, yeah, that's the website. Also on SlideShare, you can see some presentations. It's some good materials there.
So let's move to the next question. It's a quite long one, and maybe out of scope. If not time, I could contact you later on that. I saw you developed an insect incubator tech. Do you develop it next to the barns using waste from chicken?
It can be possible. It's not. It's an issue of contamination and delivery of waste materials across any nation. So they can eat the waste from the chicken, but then there is a problem moving this larva, these swarms, out of the chicken farm because they are contaminated. So this is an option in Africa and some countries that can support this kind of work, but usually the insects eat quite good food from food factories and from fruits and vegetables because they don't filter anything. Everything is like goes through them, and if there is some contamination in the food, the insect also has the contamination in its protein. So my incubator tech is for the growing and automatic harvesting of the insects without the farmer having to deal with anything. It's like a clean tech more than agri-tech issue.
So let's move it is as well from the same guy who made the previous one. So your test with the metabolic robot from Mars station simulation. Can you tell us a bit about it?
Yeah, sure, of course, thank you. I've connected some space agencies to promote really the concept of using insects as bio-waste recycling in future space travel. There is not yet a determined system in the space ecosystem that is determined on how to use waste, what to do with waste, and the most logical thing is not to throw it away because the resources in space are really short. So we have to find a good way to reuse the bio-waste, and with the larva, with the insects, we can do this in a very good way, capturing all the material and taking it back to reuse. So I'm doing some work. I'm also doing some work that is related to space without metabolic by building now a space station in the desert of Israel for the Space Agency of Europe in Israel to do analog testing there. I will put a recycling unit there in this analog space station in the Ramon Desert. And whatever test we run there, I will try to publish. And anybody is invited to also visit this test that will run in October through the D-Mouse Association or the European Space Agency, but it is really out of scope of this product or case study.
All right. So thank you, Ziv, for your answers. And okay, I believe you were curious about the question regarding the feeding. Here we are. So what are you doing when you see a bad feeding behavior?
It's the computer. First of all, when it detects an issue, it tries to correct it with changes to the frequency of the motors inside the feeding barn. This is actually what is actually done. When the animals become stubborn and do not want to play along with the computer for some reason, it can be a fence that the farmer put there, or it can be some sun that attracts them to a different location, or any issue. So the computer is limited because it tries to do something, it checks if it's been helpful and it's still the problem is there. So that's it. We only can alarm the farmer there is a problem that is consistent in each hour or each day, etc. He sees that the animals are not feeding as expected, and the farmer remains the main actor. We do not replace the farmer. We just help him with 4 or 5% at the bottom line.
Right, thank you. So let's see if there are any more questions.
Or sometimes save the entire flock from catastrophe. This is also happened.
All right. So thank you, Ziv, once again. So let me, well, I will display your email address, of course. Once again, please just write to Ziv in case you have any inquiries. And I believe you are more than happy to answer as you did it with us today.
Thank you very much, everybody, for listening.
Thank you for your time, and Ziv, you're always welcome on the BCF board. So if you'd like to join us, and I'll be more than happy to have you on board. I would like to remind, I don't know which one of your studies, but you receive actually, I don't know if I can say or not, but you receive a special honorship, I would say. So
Thank you. I'm happy everybody liked the materials and are interested. I believe this can be a change in agriculture when the big players decide to adopt high tech. It is not just sell and forget like they do today with equipment. This is being part of the process that is done at the farm, not only selling the equipment. High tech means you give service, you are responsible not for the outcome, but you are responsible to give the answers for the clients. And the big companies of the agriculture equipment have to consider that it's not only the salespeople. From now, they also have to support service personnel, and then it will be the next generation.
Which is something that we will just kind of anticipate another case study that we will see today later. And about the honorship, if I may say, just you received the honorship from the Prime Minister, if I can say the.
Yes, I did got awarded in 2014 for entrepreneurship and innovation here in Israel with a very prestigious award from the Prime Minister office here. It's been a great honor to have this on my resume, and I believe that is for the way I've done with especially this product from the vision when scouting the industry for the biggest problem and addressing it, and disturbing everything from the basic, bringing new data that was hidden until today. I hope this will be really the future of the animals, because we get to better the welfare of the chicken, and they are more happy when they come to the supermarket, and the farmer is happier, and everything is just better with technology.
Thank you, Ziv, for joining us once again today. And I repeat, we are always welcome to join us to be on board. Just of course, I will reconsider you to be part for the next annual.
Thank you for the invitation. I'll be happy.
And feel free as well to follow the rest of the conference and to use, of course, on Streamer the private chat if you have any questions to the upcoming speakers.
Thank you, Roger.
Have a great day. Have a great day, Ziv.